Welcome to chapter 5. In chapter 4, we just closed about how data is transferred from USB to the microcontroller and what are its requirements. In chapter 5, we'll see what are the reset and programming circuit requirements. So going back to the microcontroller data sheet, reset. Yep, here is reset control. Reset control has 4 reset sources: power on reset, external reset, software reset, and watchdog reset. Power on reset is when the chip gets power initially. External reset will be what we'll be concentrating on because that requires external power. So here it says that external reset is generated by a high level applied to reset pin. The reset process is triggered when EN reset is 1 and the high level duration of reset pin is greater than the threshold. When the external high level signal is cancelled, the hardware will automatically delay TRDL to remain the reset state. After the delay, CS552 will be executed from address. So if we put the reset pin on high, that is connected to VCC or 3.3 volts, then it will get into reset mode. Once you release the power from that is you take off high, then it starts a delay counter, and once the delay counter is run to 0, it starts from 0. So this gives us clear information what needs to be done. So coming back here, let's say we want a switch. Switch SPST switch push. This is good. So we'll take this. We require a resistor. Resistor again 0603. I'm keeping some standards here. If you want, you can go with other form factors as well. Let me take the lower of these two, VDD and 3.3. Let me take 3.3 itself because that would be from internal LDO, and that is what the microcontroller also understands as one of the pinpoints. So here we can generate a label called RST or reset. I'm placing that reset here. Again, this reset needs to be connected to the RST pin here, so that we have RST connected. This takes care of the reset control. Now coming to boot, or how do I send the boot command? So for that we need to look at a particular page. Let's say I'm just traversing through. I've read this particular 75 page booklet already. It should be somewhere about 30th page. Here it is talking about 3.6. It's not somewhere. Yeah, bit USB IO. This is what I was referring to. USB, UDP and UDM pin bit enable. This, when selected as 0, they both of them work as GPIO pins, right? When selected as 1, 3.6 and 3.7 selected for UDP or UDM controlled by USB module, and these directories are not available. Okay, so we need to put either one of the pins as 1, right? So we can go with 3.6 specifically because of this particular factor, and also there is a sub factor to it. I'll explain that once we design this. So what we can do is, again, let me borrow this particular thing. Here we'll have it connected to 3 volts again, and this it goes to P36. P36 also goes to this pin. So I can eliminate this and this and directly replace and D plus. Yeah. Okay. Going a bit off recording here, because most of you guys would be using Arduino IDE. There is already a library for this particular CH552 to program on Arduino, which uses this particular pin 3.6 itself and not 3.7 as the communication pin. It will be communicating on 3.6 and 3.7, but when you press the button, when you put I on 3.6, it would recognize. I'll show you that on the board definitions as well. That's what I'm waiting here for. Just a second. Okay, the Arduino IDE finally opened up. So I've selected the board CH552 here. So if you see the bootloader pin here, it works at 3.6 volts. Sorry, pin 3.6 pulled up. So that's the reason why I'm utilizing it on 3.6 itself and not on 3.7. But for all practical purposes, it might theoretically work on 3.7 as it is given on the datasheet. Okay, so we'll utilize this D plus connected to the 3.6 pin. So this is what the programming interface and reset interface looks like. This is for reset and this is for program. Okay, thank you.